Hello and welcome to another Java tutorial. In this tutorial, I'm going to continue our discussion on Java native interface. And so far, we have looked at how to call instance and static methods of Java objects that we create, right? So for instance methods, we need to call them on an instance object. For statics, we call them on the class itself, not an instance. But then there's a very interesting feature in JNI that we can use in C++ when we are calling a method, which is the option to call it non-virtually. So by default, all methods in Java are virtual methods, which means any subclass can potentially override any method in the superclass. Obviously, the exceptions are when we define a method as final, then it cannot be overridden in any subclass. But for a method that doesn't have any final keyword, this means that virtual methods means that any method can potentially be overridden by a subclass. So if I have this very simple class hierarchy, right, inheritance hierarchy, I have animal as the superclass and dog and cat as the subclass or subtype. And if you recall, when we were trying to call a method in a class and an object, we said that we use the call. We ask JVM to do call. If it's a static method, we also add the keyword static here, and then the return type, and then the method. And obviously, we have to pass in the J object, a reference of a J object for instance method, or a J class for a static method, and also the ID, the J method ID of the method, and then a vararg as for the parameters, right? But then again, for the methods, the type here is determined by the return type. So it's a primitive. If the return type of the method in the Java object is primitive, we use, for example, double or int or void, right? Void is also considered a primitive. If it's an object, any object, here we replace the type by the object keyword. So call object method. This means call a method that returns an object, a Java object, Java class. So the problem is that now obviously calling and accessing virtual methods has some runtime overhead, because in the runtime, during the running of the Java code, Java program, the JVM has to traverse the hierarchy tree each time we are calling a method, and then figures out, basically JVM has to figure out which method to call, the method inside which class. So if animal has a method called speak and dog and cat both override that method, then if we declare a reference as type animal and then say it's equal to new dog, because the animal reference is still pointing to animal class, and when we say animal.speak during the runtime, so the compiler, basically, if you look at the bytecode, the compilers the way the compiler does method binding is that compiler doesn't resolve this inheritance behavior, right? Compiler does in the bytecode, just compiler says call the speak method inside the animal class, even though the actual type that we create, the actual object, is of type dog. All right, but then compiler adds the instruction that compiler adds to invoking that method is invoke virtual. So it tells JVM, go and call or invoke the method in the animal, the speak method inside the animal, but invoke it virtually, which means you have to traverse the hierarchy tree and figure out the actual type of the object and call the speak method inside that actual object. All right, so the compiler doesn't resolve this kind of inheritance. It just does a very simple method binding to the actual superclass, and then only adds the instruction to the JVM. So it says it's invoke virtual, and all method invocation in Java in the bytecode are always virtual methods. All the invocations are always virtual. For constructor, it's invoke special, because again, constructor, as we discussed in the previous lectures, is a special type of method. But then let's say we are in the C++ and we want to call, even though we pass in a dog object to the C++, we want to call a method in the superclass, which is animal. So if I just take the call and say call void method inside, we pass in the object, this is equivalent to traversing the hierarchy tree. If we don't want And so with this instruction, with the JVM call, let's say void method, we always end up with the method that is specific to the type, right? But then if we want to always, let's say we pass a dog class and we want to call the method inside the animal class. So how do we do that? We have to then instruct the JVM that, hey, I don't want to virtually traverse I don't want you to invoke this method virtually. Basically, I don't want you to traverse the hierarchy tree. Just invoke this method inside this particular class. So we use the non-virtual keyword in this function. So call non-virtual, whatever the type of the return type of the method is, and method. So we instruct the JVM, take this J object that has been passed to C++, go to this class, J class, it could be animal, dog, cat, whatever, and this is the method ID, all right, and invoke this method. So when we use the non-virtual, we have to specify the J class also. We tell JVM, take this J object and go and invoke the method inside this particular class. So this, even though if I pass a dog object and I specify the method ID and the J class of cat, so the JVM goes and invokes the method inside the cat, even though the type here might be object. And I think it won't complain about the types, so typecasting, etc. But we'll see. We'll try it and see. So when we use this non-virtual keyword, it hints the JVM that it does not need to traverse the inheritance tree. Just go find this J class and call this method inside this J class, regardless of what the type of this object is. J class indicates to the JVM which class is to be used for the particular method. So another use case is that, as I said, sometimes we want, even though we pass a dog object to C++, we want to call the method inside the superclass of this dog, which is animal, right? So that's another way of, that's another use case for calling a method non-virtually. We say that call non-virtual method. So here's an example. So let's say I have created this animal, dog and cat. They have this speak method, and dog and cat are basically overriding the speak method inside the animal. So I find this J class identifiers and then the J method ID for the speak method inside each class, animal, dog, and cat. And know that if we want to get the method ID of the dog speak method, we have to pass in a dog class, a J class that references the dog class, that has the meta information about the dog class. And then if I just say JVM call void method, because let's assume that the speak doesn't take any parameters and returns no parameter, the return type is void. If I say just call void method, basically I'm using this instruction, this function, and passing an animal object and say go and the method ID is animal speak ID, all right? So what this does, it invokes the speak method virtually, which means during the runtime, JVM looks at the type of this actual J object, animal. If it's an animal, it invokes the speak in the animal. If it's a dog, it actually invokes the speak inside the dog. If it's a cat, so this call void method is always a virtual call, similar to what we do in Java. But then if I add the non-virtual keyword, so call non-virtual void method, what happens here is that now the JVM basically, I say, okay, the J object is this, but go inside the animal class and invoke the animal speak method, all right? So I'm passing it the method ID of the speak inside the animal class. What this happens here is that in this case, even the type of this object, even if it's dog or cat, the speak method inside the superclass, which is animal, is going to be called. Now another example is here. So call non-virtual void method, call this method on this animal object, use the animal class as a reference, but then the method ID is dog speak ID, and this is a non-virtual method, non-virtual invocation, which means the JVM doesn't care about the hierarchy tree. It just goes inside this dog class, because we are referencing the method ID of the dog method, and then calls that method. So if I use this one and pass dog, cat, or animal, always the method inside the dog is going to be used. If I use this method, this function call non-virtual void method, and use the method ID of the animal class, regardless of whether I pass animal, dog, or cat, it's going to always invoke the method speak in the animal class, in the superclass. All right, so let's head to Eclipse and try to basically investigate this. So I'm going to create a new package called test17, and I'm going to create my class hierarchy. I start with animal, and then I just create a method called public void speak, and here I'm going to do a sysout on this is an animal. All right, and I'm going to create my cat and dog, cat, and then it's going to be animal in test17. All right, so this is basically inheriting from my animal, and I can override the, so override implement, I can override the speak, and then say that sysout this is a cat. And then obviously I can also create a dog, and then finish. Let's just manually add the extends animal, and then let's do override of the speak, and then let's just do a sysout here. This is a dog. All right, so let's create a class that we test this inheritance behavior, test inheritance. Let's have a main method, and in the main method I'm going to create test1, and let's have this public static void test1, and here I'm going to create an animal equals new animal. All right, and then animal cat is new cat, and then let's do a animal dot speak. Let's create a dog, animal dog is new dog, and let's do dog dot speak, and then cat dot speak. All right, so if I run this, what do we expect? So we are using subtype polymorphism, subtype polymorphism. So polymorphism means we can use a subclass whenever a superclass is expected, which means that if only the type of the reference doesn't matter, right? It just exposes which methods we can call. But because all those calls are going to be virtual calls, JVM looks at the actual type of the class to see which specific method to invoke. So JVM at runtime resolves the invocation. So what does the compiler do? So let's run this first. So we see that this is an animal, this is a dog, and this is a cat. And the reason we see these behaviors because all these calls to the speak are virtual calls. So the type of the reference doesn't matter. The type of the actual object matters at runtime. All right. So let's see what the compiler does. So compiler has to bind these calls to the method in some class. So let's see what compiler does. So on line 7, so if I zoom a little bit, yeah, so we see the line number and then the bytecode here. On line 7, we create this animal, right? So the instruction is new, which creates an animal, and then invoke a special. Obviously, it has to invoke the constructor of this object animal. So remember, the constructor here is invoked from the animal class. And the name of the constructor is init inside the diamond brackets. It doesn't take any parameters. And as we mentioned before, the constructor signature always returns a void. Even though when we create a constructor, we're actually returning an object. In the signature of the constructor call, the return type is always void. All right? Because it's a special type of method. That's why it has a special instruction, which is invoke special. And then on line 8, what happens here is that basically we are invoking this speak method, and again it's a virtual invocation, and as you can see, it goes inside the animal class and invokes the speak, which takes no parameters and returns void, right? So the speak method inside the animal class is being invoked, which is what we expect. What about the dog? Here it creates a new dog correctly. Even though the reference is animal, it creates a new dog, and obviously it has to invoke the constructor of the dog, which is correct, but then it has to invoke the and then we know that this automatically invokes the constructor of the animal also because of the constructor chaining. But then what happens in the next line, 11? So invoke virtual. Again, invoking this method is always a virtual invocation, and but what the compiler does for method binding, it binds this invocation to the animal.speak instead of dog.speak, right? So all these all the invocations of the subclasses are binded to basically the superclass. But the instruction that the compiler gives to the JVM is virtual invocation. Invoke virtual, invoke virtual. So invoke virtual from the animal, the method speak. And then the JVM traverses the hierarchy tree and figures out what type of object this is, and it invokes the most specific version of that method. Similar for the cat, we are constructing a cat object, so we're calling the cat basically constructor, and then we are calling this speak method inside the animal, right? And then but the instruction is virtual, invoke virtual. So the compiler, the method binding at the compile time is always to the superclass. But what happens here if I change this type to cat? Now, yeah, because the reference type is cat, it binds this call specifically to the cat.speak. It's just because that's the most specific one, but when we use this reference of the superclass, the method binding happens for the superclass with the invoke virtual, so that the subtype polymorphism can work, okay? But as I mentioned, let's create a native method now, public static void call speak, and we send an animal. So let's and this is going to be a native, so it doesn't need anybody. It's going to be implemented in C++, and we create a new test, public static void test2, and let's create our objects. But instead of calling the speak on these, I'm going to invoke the call speak and send them to C++. Call speak. So we are going to call the speak method on these objects in C++. All right. Obviously, I need to load the dynamic library, system.load library, and the name of the library is native_C. So what I need, and also let's invoke test2. If I run this now, I get the unsatisfied link error. Oh, actually no, because I tested this before. But what we need to select our Java file, go to the C++ perspective, and run the Java H tool. And then it creates the header file, test17, right? And then we need to create a source folder, a source file, .cpp file. And then let's call this call inheritance, or call nonvirtual method.cpp. And the very first thing that we do, we include that header file, header test17. All right, and then we copy and paste the prototype of the function, and then we provide a body, the implementation. So the first pointer is JVM, JClass is a reference to the calling class because it's the static method, and JObject is the animal that we are passing. All right, so let's say I want to actually use subtype polymorphism in this call, which means if it's actually a dog, I want to call the speak method inside the dog, and etc. So what I need to get a hold of the JClass. Animal class is JVM, find class on the class path, and the class path is test17 package, and the name is animal. So I'm just getting the J class of the animal class, and then J method ID, because I want to invoke a method inside this class, animal speak ID. JVM get method ID, and this is not a static method, so we're just not going to use the static inside the function. In this function, we just invoke the get method ID. We pass in a J class. The name of the method is speak, and the signature is it doesn't take any parameters, so empty round brackets, and the return type is void. All right. Quickly go back here. It doesn't take any parameters, and the return type is void. So, and now we need to invoke the method. So the first case, so case one is virtual invocation, which means we want to use polymorphism when we actually call this method, right? So we want to use the polymorphism capability that the Java provides. So JVM call, we're not going to use the static, and it doesn't return anything, so it's more like the void. It's more like a primitive call void method. The return type is void, and we should pass a J object because this calls an instance method, so it has to be invoked on a J object, an object that has been created, and our J object is animal, and the method ID is animal speak ID, and it requires a var arg for the parameters, which this method doesn't take any parameters, so I leave it empty. So this works. So we expect here that this invocation is virtual invocation, which means if I pass a animal here, it should call the speak in the animal. If I pass a dog, it should call the speak in the dog, and etc. So let's compile this. It compiles fine. Let's copy and paste the dynamic library inside the Java project, and let's go here and run this test too. So I expect to see animal, dog, and cat. Let's run this. Animal, dog, and cat. So this is the expected behavior from the Java perspective, right? From the view of Java, the subtype polymorphism should work. But in JNI, we have another option, case 2, non-virtual call. Let's say I really want to call regardless of what object is being passed here, of the actual type, I want to call the speak method inside this animal class, right? So this is equivalent of saying that if I have a dog, for example, basically if I'm in dog and I want to call the actual speak inside the superclass, which is animal, I can use the keyword super, right? Super.speak, and this tells JVM actually go to the superclass and call it, right? So here in the JNI and C++, we can do the same thing with the call non-virtual void method. So what happens here? We are telling the JVM, take this J object instance animal, but use the animal class, and then call the speak method inside this animal class. Non-virtually. Non-virtually means it always, regardless of the actual type of the object, it always calls the speak method inside the animal class. So I'm going to comment this out and compile this again, and then do a copy and paste, and then I'm going to go back and run this again. So what do I expect in this case? I expect to see animal call, animal call, animal call. So let's run this. This is an animal, animal, animal. So it ignores the class hierarchy, inheritance hierarchy. It basically ignores the polymorphism and just calls this method non-virtually, just calls the speak method. Now let's say regardless of the type here, animal, dog, or cat, I always want to call the method inside the cat. Now obviously in Java it's impossible. We cannot do that, because the only way that we are allowed to do that, we are basically, let's say I have this dog object and I'm passing it to a method. I want to call a method that is inside the cat. So obviously I have to typecast it, and then after I typecast it to a cat, and then I should be able to call the speak. And this obviously throws an exception, class cast exception. So Java doesn't allow this, but let's see if we can actually do it in JNI, in C++. So what do? I need to get a hold of the J method ID. Let's call this cat speak ID, and then also let's get a hold of the cat class find the cat on the class path, and then the cat class. So I'm getting the method ID of the cat method, the method that is specific inside the cat. And then now I'm going to create a non-virtual call, but this time I'm telling it to go to the cat class and call the cat speak ID, all right, regardless of the type of this animal object. So let's see what happens now. So let's compile this. Compiles fine. Let's copy and paste. And now here we are creating an animal, sending it to C++, and it's supposed to call the speak method inside the cat class. So let's see if we actually get the cat, 3 cats here. Yes, we do. And this is very bizarre, but that's something that JNI allows us to do that. That's because here in the C++ we have unrestricted access to the meta space. So we can do these kind of things, and the JVM allows us to do that. So even though I'm passing a dog object, basically in C++ it completely disregards of this dog, and then goes and calls the speak method inside this cat class. So what if the class that we are passing the object is actually not inheriting from the animal? Does it work? So public, I'm creating a class called dummy, public void speak. Now let's see, even if it doesn't have the speak, does it work? So I'm creating a new dummy class, dummy new dummy, and then call speak dummy. Now obviously it expects an animal, so let's extend animal, and then let's see what happens here. And it still goes inside the cat subclass and calls that. So even though this dummy didn't have any basically a speak method, so that this dummy didn't override the speak method inside the animal. So if I do basically dummy.speak, because I can do, because it inherits this from the animal, Java, it goes inside this animal class and invokes this. But in C++, we are specifically instructing the JVM to disregard the class hierarchy, go to the cat class and call this speak method inside the cat class, right? Now obviously basically so if I run this, as you can see, basically this is an animal, so this works fine. But if I basically change this type of animal to object, a very generic case, does something change? Let's see. No, it didn't change. If now that I have object, I don't probably need to even extend this dummy class, this animal. The dummy doesn't need to extend animal. Let's see what happens now. It still works fine. So this is a very bizarre behavior. Basically, we are completely overriding the polymorphism. We're saying that whatever object is passed here, disregard that, go to the cat class and call this method speak, all right? Completely regardless of what kind of object is being passed. So this is kind of a little bit dangerous, but at least for the cases that we are passing a subtype and we want to always call the method inside the superclass, this is the only way. We have to invoke the method non-virtually and pass the J-class reference to the superclass and the method ID of the superclass, so that we can always call the method inside the superclass. So I hope you enjoyed this lecture. Please stay tuned, and I'll see you in the next one.